Hello, my name is Dominik Lutchman. My student number is 400143228, and this is my Comp-Eng 2DP4 final project. So the purpose of this project is to develop an analog to digital convergence system to acquire the inclination angle measurement data from 0 to 90 degrees on two different axes using the ADXL 337 breakout board. So the purpose of this project is to explore the concepts of data acquisition, which in this case, this breakout board will act as a transducer. Transducer is a device that converts a physical phenomena into a voltage signal. And in this lab, that will convert the static acceleration of gravity into a voltage signal, which will then be sampled through the Arduino. And that sample value will be used to calculate the angle of inclination using linear approximation. So for this project and the requirements based on my student number, I have to sample the x-axis data through channel 5 with a 12-bit resolution at a bus speed of 8 megahertz. And to sample the y-axis, I am using channel 6, as that's the next one over. So when calculating my baud rate using the given requirements, I'll just quickly go over it. I just talk a lot about it in my lab report. I basically just went through all the different baud rates, used the formula for a baud divisor at a 8 megahertz bus clock, and the baud rate that gave me the least amount of error with the baud divisor was the one I went with. So 38,400 is the baud rate that I'm going with today, as that resulted in an error of 0.2%, which was the lowest of any of the baud rates. Here is my circuits. These are the BCD values, most significant, least significant. This is a mode value, so this turns on when we're sampling the x-axis. This right button here does start and stop. This left one here converts the modes. There's the sensor, and there's my Arduino serial number. There we go. And just for the bonus, just in case this is for it, these buttons are based on the interrupt. I'm using a port PT0 and port PT2 to use these interrupts, and they are on the falling edge, and these pins are internally pulled up, so these buttons ground them to create a falling edge. So now let's test out the circuit. So if I turn it on, as it's right now on stop mode, we'll see that it turns on. We're sampling the y-axis since this LED is off. So if I start turning this, we'll see that the values go up to almost 90 and then back down. And then I'll change the mode. You can see this indicates that we're sampling X. So now as I start rotating on the x-axis, we can see it go up and almost hit 90. So now I'm going to demonstrate this on Octave. I do not have MATLAB, so I coded it on Octave. So as you can see, here's the plot. We are currently sampling the x-axis values. So as I rotate this in the x, we can see the plot on MATLAB go up and up and up. And then we'll go right back down. Now I'm going to switch it to Y. That LED turns off. We're sampling Y now. So as I turn it in the Y direction, we'll see the same thing occur. The plot goes up and up and up to almost 90 or 290. And then we go right back down. So now to test the functionality of my stop button, I'm going to press the stop button to indicate that it stops the communication with the computer. So I press the stop button. As we can see, all the LEDs turn off and the plot stops plotting, and no matter how much I move it, nothing will be plotted. This is my final project for Comp-Eng 2DP4. Thank you for listening and have a great day.